Okay, so my name is Yngve Kinsland. I work in Bouvet at the data science department. I have the pleasure of giving this talk about a practical implementation of machine learning for a specific case. So this will not be about theoretical considerations regarding deep neural networks or something like that. It will be the practical issues of doing machine learning. So this is my department. We think of data science as a teamwork. We have the data science part here, which is kind of the hardcore statistics, mathematics part, where the architecture part, the nitty-gritties of importing, transforming data and storing data, data analysis, the more top layer part of data science, and then you have the visualization part. And we consider all these parts as essential for giving something good to the customer. So I myself, I'm placed here, but I also work here, also work a little bit here. But this is kind of my core skill. So what we do in Bouvet in this department is we help companies doing the digitalization journey. We try to make them work more in a more agile way. We look, instead of having a project organization, so instead of having an organizational organization, we try to organize around products and try to go from data in server rooms in the cellar to cloud-based solutions and so on. We try to kind of help them going from kind of an old-fashioned way of thinking to a more modern way of thinking in an agile way and a focus on value realization. So what I've been working with for the last 2.5 years is the so-called data lake in the municipality of Bergen. The idea here is that the municipality, they by themselves own lots and lots and lots of data, but they are not shared between departments, and they are definitely not shared with the community, the citizens of Bergen. So we have had an idea of collecting all these data in a cloud solution and make them available. And we'll do this so that we can look at opportunity for using data from different sources in different applications, and maybe we can gain some new insights. So that has been the idea of this data lake. What is a data lake? That is kind of the core of a digital ecosystem. We collect data from internal system, external system, and Internet of Things. This goes into the data lake. We load the data, we store the data, we transform them, and we enrich them, we structure them, and then we use the data. We transform them so that they can be easily used for different visualizations, analysis, and some logics. And of course, this requires governance, monitoring. Yeah, you have to look after your data. So yeah, this is in more detail. We have the data sources that go in. We So we collect those, we transform them, and we make them available in a surface layer for the customers. Then we can use these data. And this is what this machine learning project has been about: use data in a data lake in this in Bergen. I don't know quite why I did put in this. Here is a diver in this data lake, and he wonders, if I collect all these data and I turn on machine learning, will I then know everything about my data and must problems are solved? Some people think so. If you just put in data, something good comes out, but no. It requires some more effort. In the data lake, a central actor there has been the water department of Bergen, water and sewage department. Why this is very cool to work with is because they have 13,000 sensors all over the city that measures something every minute. So they collect a vast amount of data all the time. They measure water quantities pumped out to the households. They measure how much sewage is pumped through some pump stations. They measure salinity, oxygen levels, a lot of things. And traditionally, these data, they have been coupled to maps, and they can then have they put this. They have this system called Gemini, where map information and sensor data are combined. I think I'll skip through these. Yeah, they have this system called Gemini, where they can inspect these sensor data and combine them in map data, like this. Yeah, and these are the sensors. They're spread all over the city. So there's a lot of them. This has been a great value, of course. They can, when they see something odd, they can go into this map. They can take out the cars, and they can immediately find out what is wrong. But what they have not done so far is to try to avoid such catastrophes like this by kind of predict what should be measured. This is a leakage in a sewage pipe, and the idea is, can we detect such disasters before they become this big? And there was taken an initiative last summer. There was a student that did some machine learning on this, and the results were so good that we were given the assignment of taking this further. So the idea is, we have these pump stations for the sewage, and in each of these pump stations there are sensors that measure how much water goes through these pump stations. If we could estimate how much water should go through these through an estimation algorithm, and compare this to what is measured, if there is a disagreement between the estimated value and the measured value, can we then say that, okay, something must have happened to some pipe or some other part of this system? That is the idea. We want to see if a disagreement between estimated pump values and measured values is actually equivalent to something wrong. There is something wrong in the system. So the point then is to identify how we can do these estimates, and what will be input to this input layer of our neural network. Where does the water come from? Of course, there's personal water use. We go to the toilet, we shower, we do the dishes, and then there is water coming directly from the surface of the streets, like this. And all of this goes into the pump station. So what could be variables describing this input? Yeah, this is an image of what the student did last summer, and as you can see, it was quite promising. The orange line is the estimated value, and the blue line is the measured value of pump station values. This is what goes through the pump station. And we can see the trends are the same. Of course, there are some discrepancies, but it is sufficiently promising for the water and sewage department to go further with this. So our project, first of all, we had to collect the data that we need as input. And what could be input? Temperature, precipitation, the tides actually. Some of the pump stations, they are located at only a few meters above sea level, and actually some of these pump stations take in seawater when the tide is high. So that is actually an input to some of the pump stations. Snow depth, holidays, weekends, everything like that. Then we use these data in the data lake to build a model and to do estimates. And for this, we use the Azure Machine Learning Studio. And then we need to further develop the model in a new neural network, maybe take in some new data. And this is where we are right now. So more details on what will affect the water amount that goes through the pump station. As we talk about, we have the private water consumption. And obviously, the private use of water varies with weekday. We spend more time at home in weekends. And probably we use more water then. When we are on vacation, we stop using water at home. The time of the day, obviously we spend the most water in the morning, maybe in the evening. And maybe also the weather and the time of the year has some impact on how much water we use. If the weather is good, we are maybe more outside and spend less time in the house. Maybe we then spend less water. We can actually gain information about we can actually gain information about the private water consumption from other sensors that the water department also owns. But it's a bit tricky because these sensors, they show how much water is used in a quite large area of the city. So it's difficult to know which water sensors to use for a certain pump station. The drainage area for a pump station does not necessarily coincide with the sensor that measures water consumption. So yeah, that's why I put this in parentheses. I'll come back to that. The surface water that comes in, that is obviously impacted by the precipitation. Then we have snow melt. When there's a temperature and there is snow, there will be snow melt. The temperature affects this. If it's cold, the water freezes instead of going into the ground. And then, as I talked about, there's a tidal water, which is then seawater coming in. So it's a rather complex situation that we have to describe here. So what have we collected? We have collected precipitation and temperature data for 18 stations in Bergen. These were collected from the Institute of Meteorology at what's it called? yr.no. Later on, we imported some other data from some institute, because these turn out to be not so useful. I'll come back to that. Then we have tide water tables for 2 locations in Bergen, and then of course we have the sensor data. We have the amount of water coming up from pump stations, and we have the water consumption measurements. Yeah. When we were to do the practical implementation of this, we chose to use what is called Azure Machine Learning Studio. This is taken directly from Microsoft's pages. It's a cloud-based service for creation and managing of machine learning solutions. It's designed to help data scientists and machine learning engineers to leverage their existing data processing and model development skills and frameworks. That was the commercial. But it is actually rather convenient to do things in Azure Machine Learning Studio. It helps you get to the data and helps you make versioning and so on and so on. So then this is the architecture of the solution. We collect data from met.no, the weather source. We import tide water from Norwegian, those who produce the maps in Norway. Then we have sensor data from the water and sewage departments in Bergen. All these data, they go through different components in Azure, Data Factory, Databricks, and Azure Functions. They are transformed and then they are put into SQL tables, SQL tables. Some for weather info, some for tidal waters, some for the sensor data. And then we have some dim tables for how to do the training, which data should be used against which pump stations. That of course has to be put into the data. Then all of this goes into what is called a data store in Azure Machine Learning Studio. This goes into the training pipeline. That results in a model, and this is exposed in a web-based endpoint. And then using this endpoint, we can take data again from data store, and out comes the long-short estimates of what should go through the pump stations. Okay. So some details about the neural network. This is the input layer, and what goes in here is the month, day, which weekday, the time. I forgot to say the resolution of all the input data is 1 hour time resolution. And we put in the last 24 hours of precipitation, 24 hours of temperature, and 24 hours of tidal water. For some pump stations, we also put in water measurements, the water consumption measurements. So that also goes in for some of the pump stations. Then there is a hidden layer, and then there's an output layer. And this is then the estimate of what goes through the pump station. There are, of course, more details about this that I can talk about, but I think those are details that, yeah, as I said, I will not dive into theoretical considerations in this lecture. Satish is better on that. When we had got started, we of course found that we had duplicates in our sensor measurements. And for some time points, there were several values, which of course does not make sense. So we have to figure out what has happened there. And there were missing sensor values and so on and so on. So of course, we should have checked this before starting on the project, but we had been told that this data should be okay, but they were not. So it took us a month or two to fix this. Then later on, it's turned out that data from met.no, they were not good either. There were holes in data. Some of the measurement stations, they stopped functioning for long periods. And some of these stations only measured temperature. So after some time, we concluded that we had to find a new source for weather data. One crucial point was that there were no functioning weather stations in Arna Valley, and that is not good because Arna is kind of separated from the rest of Bergen geographically. We have Ulriken in between. So yeah, so that highlighted that we had to find new sources for weather data. Yeah, this is just a map showing Bergen. This is the north tip of Bergen. And it extends down to about here. Then it goes east all the way to Trenger here. And Arna is here, so it's kind of separated from the city of Bergen here. So we need measurements of weather also for this area here, if we are to do good estimates of what goes through the pump stations in this area. So we need new data for weather. Instead of meteorological observations, we went to post-processed weather forecasts. And that is weather forecast corrected with actual measurements. And these are provided also by Meteorological Institute. They actually use a collection of privately owned weather stations, Netatmo. This is a map showing the locations of the Netatmo stations in Bergen. It's quite cool. You can buy your own weather station and you connect it to this Netatmo network. So if you do that, you enhance forecasts from the meteorological institution. Yeah, so then finally we could produce some estimates. Now I'll switch to 2 secs. 2 seconds. I will be there. There we are. We have put all of our results into Power BI solution, and on the left here we have the list of pump stations. It's about 150 pump stations, and if you click on one of these, let's say Buntelabo, we get curves for, let's zoom in a little bit, that shows sensor values, estimates, and the difference between the two. What is the red line here is what is called the new estimate, and that is with the new source for meteorological data. The blue is the old one, based on sensor or observations. And this is the difference between new estimate and the sensor values. So what we can see here is that the estimates mostly follow the sensor values. What is measured in the pump stations is about what we estimate should go through the pump stations. So this is quite promising. The line here is the difference between the estimated and the measured pump values. What we see down here is precipitation and temperature. So yeah, as we can see, it works quite well for most of the pump stations. And they're very different in how they're very different in how they respond to precipitation. Some of them are mostly influenced by private use of waters, and for example, this one is very much influenced by the weather. So then the question is, can we use this for detecting breaks in pipes? What would that look like? What we look for is large discrepancies between estimates and sensor values. So this is then the green lines here. But what level of discrepancy do we need to say that there's something wrong? And that is what we're working with now. The idea is to look at how well we did during what was used as a training period. And that is the entire year of 2020. We will look at the discrepancies here up to 21. And if we detect something that is much larger than we observed in 2020, then maybe there's reason for checking out what is going on. That is the idea. We can take some other pump station. No, that was not the one. Let's take this one. So here we have kind of an obvious example of something has happened. What we see here is that this is the measured pump values, the blue line here, and the red and the pale pale yellow is down here. And this is very consistent for quite a long period of time. And we know that there was something that happened. There was a change in the piping. There was not a break, but there was a change in the piping. They diverted some water to some other pump station, or to this pump station. So the pump values rose quite dramatically. So, and this is of course not picked up by the model, because the situation around this pump station changed at this time. I cannot kind of say very much more about the success yet, because now it's the people at the water department that try to use this, and they try to compare the curves at periods where they know that things have happened. But we are working on this now, and I think this example here shows that there is potential. And if we could have, if something dramatic happens like this, we see this within a day or two, that, okay, something must have happened. So we don't have to wait a long time to see that, okay, something has happened. We see it within hours, actually. So I think there is things can be gained here. I can then take some other. Okay, yeah. But all in all, we see that these estimates, they are quite well. They are quite good. To me, it's actually quite remarkable how well we do, considering the complexity of the input to the pump stations. What I want to find some. There was one specific example I want to show you, but I can't remember the name of the pump station right now. Sorry. What I wanted to show you was that for some of the pump stations, there was problems during January and February in 2021. And let's see if I can find it. Oh, sorry. But for some pump stations, we see problems during the first part of 2021. And we believe that the reason for this is that that was the very cold period with low temperatures below zero. So the water froze on the surface instead of going into the sewage. And in 2020, we did not have such cold periods. So the neural network didn't learn about cold periods like that. So for some pump stations, it fails quite dramatically during this period. I'll try once more to see if I can find such a pump station. Sorry. Yeah, sorry. I should have been better prepared. Sorry. There used to be a problem up till March, and the reason was, as I explained, there was a cold period, but now we have included up till March in the training period. So that was then disappeared. What we are interested in, what's happening now. So we include as much we can in a training period. So, so now we have included this cold period. So now we can cope with cold periods, hopefully this winter. One other thing I wanted to mention was that we included measurements of water consumption for some pump stations, but it turned out that it didn't have a very large impact on the estimates. It seems that the information about this information is not correlated strongly enough with what goes through the pump station that it is important when building the model. It's much more important with weather observations and the time of day and which day it is. So for now, we don't include water measurements as the input to pump stations. And that was a bit of a surprise, but we will try more on this. We will try to combine more water measurements from different areas into one pump station to see if that helps. Okay, I'll go back to the presentation now. Sorry. Sorry. Yeah. Yeah, this was just a Jan Fatens that I already showed you. I think this is actually what I had to say about this. Take-home message is, of course, that you need to really check your data. That is, you cannot do that enough. Check that data are okay. Second is, you have to understand the problem. You have to understand what you're going to model. And this project here is actually very complex. The input to the pump stations are affected by many different variables, and it's not clear what we should put in. And there are many things that we could try to put in. But again, adding too much complexity is also not so good. Then you usually need a longer training period. And yeah, so the situation is complex, but talking to the people, knowing knowing what we are going to explore is of instrumental importance. Yeah, it's not just getting the data at hand. You have to know what you're doing. You have to know what is it you're going to solve? So yeah, I think that is what I wanted to say. Do you want to add to this, Paul?
I think you thought about it in a really good way. Can't say it enough, but as Ingve mentioned, it's so important to just look at the data and then look some more at the data and perhaps play with the data and then test the data and then just look some more on the data, perhaps find some more data and then try out the different algorithms. Machine learning and data science is the coolest and most hyped phenomenons at this time, and of course, everyone want to work with machine learning when they grow up. Everyone probably will at some time, but it's really important, the data mining, the data engineering. If you want to become a good data scientist or a full stack data scientist, as we often mention them, you should definitely learn how to use your tools and figure out what's wrong with the data.
Yeah, that can't be said enough. There will always be surprises, of course, but if you can avoid them as early in the project as possible, it's definitely good.
Yeah, and when we work with our customers in the industry, it's like everyone want to do machine learning there as well to automate their processes and find new ways of doing business. But when we go in and just start with analytics part straight away, it's always we have to go back and look at the data.
Yeah, so that happens again and again. And also, it's very important to talk about the customer. Should we actually do machine learning here? Is there something to gain? But that's another discussion. For this project, it was kind of obvious that machine learning was the thing to do. So that was good. But in other projects, it's not obvious that one should do machine learning and definitely not deep learning.